Hello, let us look at some AP Calculus style questions on derivatives. So the first one here is sine of x is equal to e to the y power, and then we want to find out dy over dx. Now I know that this style of question is actually not as popular now than before, but we'll try to just go over them as a practice. You see, one thing that we want to do is that y is on the exponent, and we want to separate that, or we want to isolate that by itself. In order for us to do that, ln, meaning natural logarithm, will be a very useful tool. So here we get ln of sine of x is equal to ln of e to the y power. Now, I put the parentheses over here because when sine of the angle, when the angle is 0 through pi, we know the sine is always positive. So therefore, we don't have to have absolute value in this case. Then, by the power rule of the exponent on the logarithm, we can bring y to the front. So here we get ln of sine of x is equal to y ln of e. But as you know, that ln of e is equal to 1, so we can simply cancel that out. Then, in this case, now we are ready to find out the dy over dx. When you take the derivative, then here, first it becomes 1 over sine of x, but by the chain rule, we have to multiply by the derivative of sine of x, which is cosine of x. So essentially, we end up getting cosine over sine. What could that be? Yeah, that's right. Cosine over sine is cotangent. So therefore, that becomes our answer. Let's look at the second question. Here we have the notice that base has the variable and also exponent. Then we get to use the same strategy as before. In other words, we can use the ln. So I'm going to assume that this is equal to y. It'll be easier for us to write. So I can rewrite it as ln of y is equal to ln of x squared plus 1 to the 2 minus 3x power. Now, once again, by using the properties of logarithm, we can rewrite this one as ln of y is equal to 2 minus 3x and ln of x squared plus 1. Now we are ready to take the derivative. In one way, we are doing this implicit differentiation here. And here what do we end up getting? Derivative of ln of y becomes 1 over y. But by the chain rule, or implicit differentiation, we end up getting dy over dx. And on the right side, we can use the product rule here. Then we end up taking the derivative of the first one, which is negative 3, times ln of x squared plus 1, and then plus, writing down the first one as it is, taking the derivative of the second portion, which is 1 over x squared plus 1, and then by the chain rule, we just have to multiply by 2x. Now, but we realize that in this case, notice that x value here has to be equal to 1. That means I'm going to plug in 1 for all the values of x here and here and here and here. All right, then let us try to do that. 1 over y dy over dx now becomes negative 3. When you plug in 1 in this location, we get ln of 2. And here, when I plug in 1 here, we get negative 1. And when I plug in 1 here and here, we end up getting 1 over 2 times 2. Now, then as you can see, this becomes negative 3 ln of 2 minus 1, because 1/2 and 2 cancels out to be 1. Now that's dy over dx. But in order for us to get rid of 1 over y, we have to multiply both sides by y. But what is the value of y? In order for us to find the value of y, we can plug in 1 into the original expression. Then we get y then in this case, you can see that is equal to 2 to the negative 1 power. In other words, that's the 1/2. So here we get. And then notice that we have two terms in ln, but we don't have anything. So we got to combine them. So another way which we can combine them would have been this. I can rewrite this one as negative ln of 2 to the third power, bring the exponent. Now minus 1 simply becomes ln of e, and then times 1/2. If I were to factor out 1/2, which was already done, and with the negative sign, negative 1/2, then we get ln of 8. 8 becomes 2 to the third power plus e, because when you factor out negative sign here, then we end up getting addition, so 8e. That becomes our final answer, which is choice A. All right, let's move on to the next question. Okay, so here we have y equals tangent of u in terms of v, and v in terms of x. And then we want to find out dy over dx. Then you can easily see that dy over dx can be expressed as dy over du, multiply that by, because y was in terms of u, du over dv, multiply that by dv, and then v was in terms of x, so dx. So if you have to finish this one, then we'll be able to get the answer. Now, what is dy over dx? Dy over du. Then derivative of tangent of u is secant square u. Derivative of u in terms of v, then here we get 1 plus 1 over v square. Because derivative of v becomes 1, and derivative of 1 over v becomes 1 over v square. And then taking the derivative of here becomes 1 over x. Now, but in this case, we realize that x value is equal to e. So when you plug in e in this location, then that's rather simple. 1 over e. That's the first portion. But when x equals e, what happened to v? And I can use this one to find out the v value. Then v must be equal to ln of e. But ln of e is equal to 1, as we know. So v is equal to 1. Then the second expression now becomes 1 plus 1 over 1 square. We know that to be equal to 2, but let's continue. Now, since v is equal to 1, what is u? U then equal to 1 minus 1 over 1, which is equal to 0. So then here we get secant square of 0. Now, one thing about secant of 0 is that reciprocal of cosine of 0. But we know that cosine of 0 is equal to 1. So reciprocal of that still will be equal to 1, and when you square that, it still be equal to 1. So first portion becomes 1, second portion becomes 2, and third factor is simply 1 over e. Hence, we end up getting 2 over e becomes our final answer, which is choice D. All right, let's move on. Here we just have to find the derivative of the e to the 1 over x. It looks like we just have to use the chain rule here. Then e to the 1 over x. And what is the derivative of the 1 over x? That's right, it becomes negative 1 over x squared. Now, if I were to combine them together, then I believe that it looks like A. Yeah, it looks like A. Seems to be our answer. Now, the next one. This one is using implicit differentiation. So we just have to remember, when you take the derivative of y squared, it becomes 2y dy dx. Okay. Now, then using that, let us try to do this one. Taking the derivative of this one, Derivative of y becomes simply dy over dx. And then ln becomes 1 over x squared plus y squared. But by the chain rule, we'll end up getting 2x plus 2y dy over dx. Now, then let's continue here further. But we realize that x value is equal to 1 and y value is equal to 0. So by plugging in those values, we'll end up getting 1 over 1 squared plus 0 squared. We know that that portion is equal to 0 here. 2 times 1. And then plus the second portion simply becomes 0 because y is equal to 0. Now, then this simplifies into 2. So therefore, our answer is 2, choice D. All right, how about the next question? When you look into this expression, we are looking at chain rule, I guess, because notice that I can rewrite this as y equals cosine of 3x entire thing to the square. Then, first, of course, the square is the outermost layer, and then cosine, and then we can have 3x. So what is dy over dx? First, we have to use the power rule to deal with the square. So we end up getting 2 times cosine of 3x. Now, second, derivative of cosine, which becomes negative sine of 3x. And then lastly, taking the derivative of 3x becomes 3. Then this one simplifies into 2, negative, and 3, so therefore negative 6. And sine of 3x times cosine of 3x. And that seems to be choice A. Now, even though that is correct answer and then we finished this question, but I just wanted to continue a bit further. What if you weren't able to find this answer? One of the popular trig identity will be double angle formula for sine. We know that sine of 2a is equal to 2 sine a cosine a. If I were to borrow this idea and apply to this answer, I know that we're done with this question already, but we could have gotten something like this. This one then can be equal to factoring out 2, so we have negative 3 still left, and then sine of, instead of a, we get the double of the angle, so we get 6x. So that could have been also a possible answer. I know that it's not there, but it's good practice to think about. All right, now let's look at the next question. Let y equals x times square root of 1 plus x squared. Here we have to use the product rule to find, so you see what we are looking for is dx. Dy. Dy, simply you can think of it as a small change of y value, while change of x value is 2. In one way, it's like a slope. So here, let's look at this one. First, find the derivative, so dy over dx is equal to, by the product rule, we're going to have 1 plus x squared, because I took the derivative of the first portion, plus, keeping the first one as it is, and taking the derivative of the second factor. This is to the 1/2 power, so we have 1/2 to the front, and 1 plus x squared to the negative 1/2 power, and then taking the derivative of inside, which will be 2x. But notice, x has to be equal to 0. That means this will be equal to 0. That makes the entire second term to be canceled out to be 0. And this x squared term becomes also 0 from the first term. Then we end up getting simply square root of 1, which is equal to 1. But that is equal to dy over dx, but dx was equal to 2. So that's the equation which we end up getting. Then what is dy? We just have to multiply by 2 on each side, then we get 2 becomes our final answer. Choice E. All right, now here we have a parametric equation or parametric function, and we want to find out dy over dx. How are we going to do it? Dy over dx, as we know, is simply dy over dt divided by dx over dt. But what is dy over dt from here? That's right, it will be simply derivative of 2e to the t power is simply 2e to the t power. Nothing much more than that, because the exponent t is derivative of t becomes 1, so we don't have to do anything further. How about the second portion, denominator? Becomes, yes, 2t. Then you can see that 2 and 2 cancels out, so e to dt over t becomes our answer. Where is that at? Okay, choice A becomes our final answer. All right. Number 9. Limit as h approaches 0. Oh, interestingly, they used a variable h. Now, one thing that I want to share with you in this case would have been, there was another popular expression where h is approaching 0 for the function f of x plus h minus f of x over h, which is the derivative of the function f of x. Now, notice that h is in the denominator, so is this one. As long as I can simulate the numerator using logarithm, then it'll be okay. But notice the logarithm of the division of the values can be expressed as subtraction of the logarithms. So, in fact, it is possible for us to rewrite this one as limit as h approaching 0. Here we get ln of 2 plus h minus ln of 2 over h. Because once again, division is the subtraction on the logarithm. Then by comparing it, you can realize that the expression that's given to us is the derivative of ln of x. So derivative of ln of x, where x equals 2, because 2 is in place of x. Derivative of ln of x becomes 1 over x, where x equals 2. That means simply 1 over 2. So 1/2 becomes our answer, choice C. All right, let's look at number 10 together here. In this case, we just have to take the derivative of ln of the ln. Then, first, outer layer, derivative of ln, that gives us 1 over ln of x. But by the chain rule, we have to take the derivative of ln of x one more time, then becomes 1 over x. Now, 1 over ln of x times 1 over x. Which one is that? Choice E. Now, suppose that f is an odd function, and they gave us this information. Now, but what we're looking for is taking the derivative of the given function. Oh, wait a minute. Since x of naught, negative x naught or x, we're just going to try to find the derivative of this one first, and then replace x with x naught or x sub 0. When you take the derivative of this, we get f prime of negative x, but by the chain rule, we have to take the derivative of negative x, which becomes negative 1. That's equal to, here, negative sign was already there, taking the derivative of f of x is f prime of x. But in place of x's, if you have to substitute that with x sub 0, then we get, and then since both sides has negative, I can cancel the negative signs out by dividing it by negative 1 or multiplying by negative 1, however you look at it. And we end up getting f prime of negative x sub 0 is equal to f prime of x sub 0. Oh, wait a minute. Then this is what's given, and that's what I'm looking for. Where do I have that as the answer? Choice A. Just for your information, if you have odd function, and then if you take the derivative, interestingly, you will realize that, just as you can see over here, you'll get even function. And if you take the derivative of even function, and if it's differentiable given that, then it will become odd function. Just even and odd, and even and odd. All right, let's continue with the next question, number 12. Here we are taking the derivative of h and placing 1 in it. So let's try to figure out what's the f prime of x is first. Then first outer layer was f, so f prime of g of x. And by the chain rule, we'll end up multiplying that with g prime of x. But the thing is, in this case, we are looking for 1 as the x value. So we get f prime of g of 1, multiply that by g prime of 1. Now let's look at what is g prime of 1. That seems to be negative 3. So I can rewrite this one as negative 3. And what is g of 1? G of 1 was 2. So I can rewrite this one as f prime of 2 times negative 3. Now, but what is f prime of 2? That seems to be negative 4 here. So this now becomes negative 4 times negative 3, which will be equal to 12 as the answer. So where is 12? Okay, choice D seems to be the answer. All right, let's continue. And here, once again, we just have to take the derivative, but you can see that we have to use the quotient rule to take the derivative. So what is f prime of x? First, I'm going to take the square of the denominator, which is tangent square x. And then taking the derivative of the top, which is 1 times tangent of x, the denominator as it is, minus top times the derivative of the bottom one, which is secant square. Now, by plugging in pi over 4 in both locations, so tangent of pi over 4 minus pi over 4 times secant square of pi over 4 all over tangent of pi over 4. Now, let's try to remember what tangent of pi over 4 would have been. Pi over 4 would have been simply 45-degree angle. So tangent of 45, as many of us know, it is equal to 1. How about secant of pi over 4? Secant of pi over 4 is in fact equal to 1 over cosine of pi over 4. But we know that cosine of pi over 4 is radical 2 over 2, but reciprocal of that becomes 2 over radical 2. Now, you can simplify this one actually quite easily, saying that it's equal to radical 2. Now, by plugging in all the values that are necessary, tangent of pi over 4 becomes 1 minus pi over 4 times radical 2 squared over 1. Then this becomes 1 minus, you see, radical 2 squared becomes 2, so 2 and 4 cancels out to be 2 on the denominator, so 1 minus pi over 2 seems to be our answer. Choice E. All right, let's look at number 14 here. If f is a function such that, now, did you realize that this is the another definition of the derivatives? That's right. So this is the definition of derivatives. F prime, where x is equal to 2, or x is approaching 2. So therefore, we are looking at derivative of f at x equals 2, and then that derivative is equal to 0. So choice C is the what the expression explains. All right, we'll stop here for now, and I'll see you soon in part 2.